Okay, hope you are able to see my screen, I believe. Today is the last demo, and today let's see how we can deploy the microservices via CI/CD pipeline. So the agenda for today is designing the blueprint of the CI/CD pipeline. So agenda is designing the blueprint of the CI/CD pipeline for microservices deployment. So this is what our agenda for today. And before going with this agenda, what we need to do is we need to first identify the components of the ecosystem. What are the components that we will have in the ecosystem? Those components we need to identify. So identify the components of ecosystem. First, let us identify the components of ecosystem. So to do that, let me go to here. Let me go to microservices cloud architecture. Yeah, so if you can see the cloud architecture in microservices, first we'll have the microservices. First, we'll have the microservices. Next, these microservices will register in service registry. Then these microservices will register in service registry. Then these microservices will be protected by the gateway. So API gateway. Next, microservices will take the security tokens from this cache server. So we need the cache server deployment. Then users will be registered and then authenticated via this user management service. So user management service for the user management, and then user authentication service for the authentication. And we also need the IAM server. And for observability, we need the log management, let's say ELK or EFK components. And then for the monitoring, let's say Grafana and Prometheus components. So these are all what the components we need to deploy. Again, in microservices, we'll get in microservices, two microservices let us deploy. One is category service, and second one is the brand service. Second one is the brand service. Category service is using the MySQL DB. Brand service is using the MongoDB. Okay, so these are all the components of the ecosystem. Now let us draw the pipeline, how it will be for the microservices deployment. To do that, let me go to this draw.io and create a new diagram today, that is microservices CI/CD. Fine. So let me take the new diagram. We already know, right? So let me go to one more time, draw.io, and open the existing diagram. that is DevOps 7:15 a.m. Yeah. Right. So this is what we discussed, right, in the last session. So this is what we discussed in the last session. So what we will have, we'll have the monolithic application deployment is what we have seen. Now we need to see the microservices deployment. So careful. The first thing is what we need to understand this build orchestrator. So we have the Jenkins. So carefully observe, please. This is Jenkins master, and this Jenkins master will be attached with the Jenkins workers. Let's say Linux worker. This is the Linux, maybe the Ubuntu worker, or these are all the Linux Ubuntu. Let's say maybe this is also Linux Ubuntu, and this is also Linux Ubuntu, and one is the Windows machine. Let's say this is Windows machine. Now what we need to do, we need to take these machines as the workers of the Jenkins master, and these will talk to the Jenkins using the SSH connection. So the ideal way is what, how many microservices we have. Each and every microservices, let us target to execute on one machine, if possible. That is the case. If you have the 100 microservices, we need to have 100 machines. Again, which is a problem. Here we need to build the application. So what we can do is either we can use the machine for 2 to 3 microservices, one machine for 2 to 3 microservices, or we can use the each machine for each microservice building. This is small machines only. If it is each machine for one microservice, then definitely T2 dot micro machines are good enough. These are the open source machines, and then the open free machines, basically I mean to say. T2 dot micro machines are free machines. So we can take the T2 dot micro machines per service. 100 microservices we have, no problem. 100 T2 dot micro machines we can configure here. So each and every microservice will execute. 1 minute, guys. Just give me a minute. Yeah. So each and every microservice will execute on each and every sorry. Each and every microservice will build on each and every worker machine. So this is one microservice. 1 moment. Okay. So let's consider this is one microservice. So let's execute this on. Let's execute in the sense build on one machine, categories machine, and then the dedicatedly brands will always build on the brands machine. Products will always build on the products machine. Orders always build on the orders machine. So what will happen now? There will be different build jobs available. Different build jobs available. Meaning we need to configure the many build jobs. So one for the, this is the one pipeline. Let's say this is the one pipeline. One pipeline for what? One pipeline for category service. Let's say similarly, there will be another pipeline for the brand service. Similarly, there will be another pipeline for the another pipeline for the order service, another pipeline for the API gateway, another pipeline for the cache service. So like this, we can have the many pipelines here for all the ecosystem components. Let's say this is category service, this is brand service, and let's say this is the API gateway, and this is the service registry, and let's say this is the IAM server and security, and this is the cache server. So different pipelines will have for each and every microservice will have a pipeline. So we can take here the Git repository, and this Git repository contains the different branches. Let's say this is one branch. This is the one branch holding the code of the category service, and this is the another branch holding the code of the brand service. And let's say 1 minute, holding the code of the category service, brand service, and let's say this is not branch, actually repository. This is one repository holding the code of the gateway or service registry, and this is the code of the gateway where we have the gateway, and this will have the code for the maybe other services. So this is one more other service, maybe order service or maybe other services. Cache service and all, they don't have the code with us. Cache service, because Redis we are using, and IAM, WSO2 will use. These are all will have the already Docker images available. So we don't need to Dockerize them. So only we will take the our services in the a particular repository. So whatever we, right? So these are all the repositories where we will have the microservices. Each and every microservices code will have. Right? Hope you understood. A separate pipeline for each and every microservice. Okay, and let's take it. Separate pipeline for each and every microservice. Now, when separate pipeline will be executed, each and every microservice will execute on a particular mission. Each and every microservice will execute on a particular mission. Not one repo with different branches. These are all the repositories. This is the GitHub. This is repositories. Actually, I should have to take the repo repository symbol, but I have taken the branch symbol. So I have to take this repost symbol basically. So each and every microservice will be in one repo, whereas the repo contains the many branches. So Control Z. So this is the repo. This is the repo, not branches. Consider these as the repos, not branches. Okay. Now, each and every microservice will execute on one particular worker node. Remember this. Carefully remember this. Each and every microservice will execute on the particular worker node. Let's say here category service will execute, here branch service will execute, build, I mean to say. Here category service will be built, here branch service will be built, here API gateway will be built, here maybe the other services will be built, right? User management service will be built, or authentication service will be built. So let us take the dedicated build machines for the each and every microservice. And these microservices requires a small memory. So T2.micro machines are good enough. Now, once the build is done, each and every pipeline will be configured with the sonar quality gate. Again, each and every pipeline will have its own quality gate, I mean to say. Each and every pipeline will be configured with the own quality gate, or else we can have a same quality gate for all microservices as the Java microservices. But the case is what? If there will be a .NET microservice, then it will be difficult for us. We have to take one more quality gate. So what I mean to say is, here we have to take the sonar cube with the quality gate. Let's say here is the sonar cube and sonar cube with the quality gate. Sonar cube server with the quality gate. So not only one quality gate, there will be many quality gates we will define. For Java applications, one quality gate. For Java applications, one quality gate. And for the .NET application, one quality gate. For Python application, one quality gate. Like that, we'll define the different quality gates, because microservices can be developed in any of the technology. So microservices can be developed with any of the technology. They are technology agnostic. Assume if one microservice is developed using the Python, another microservice developed using the .NET, and one microservice developed using the Java, then these microservices should have to be go and then evaluate against the respective quality gates. So we'll have one or more quality gates defined in the sonar cube server. One or more quality gates defined in the sonar cube server. So each and every pipeline, if the similar technology, for example Java, no need, only one gate, one quality gate is enough. But if the microservice is developed using Python, the microservice developed using the .NET, then their respective quality gates we need to define in the sonar cube server. So here is the sonar cube. One moment. One moment. One moment. So we are here and copying this. So this blueprint will follow. That's the reason I'm, again designing all these things. Okay. However, it is taking time. That's okay. I'll maybe design it later in time. Or else sonar cube images. We can go and then get the images from here. Fine. So this is what the SonarQube server. Now the point what you have learned here, each and every microservice will have the quality gate. Maybe depends on its type of the technology implemented, right? So then SonarQube need to upload the results to the database. So we'll take the PostgreSQL as the database for this SonarQube server. So we must configure the SonarQube server with the database setup. Perfect. Why? Because in the database, the Sonar reports will be saved. Yes, SonarQube will be one, whereas we'll have the multiple gates, multiple quality gates, whereas the SonarQube is only one. Right. Now, once the SonarQube is done, then what we need to do? Each and every microservice, we need to, meaning the quality gate is passed, let's say, then each and every microservice, we need to upload, we need to publish to the Artifactory. So Artifactory may be the JFrog or maybe the Nexus. So I'll use the JFrog here. JFrog Artifactory I'll use. So we need to upload it to the JFrog. So each and every microservice will be uploaded to the JFrog. For what? For the versioning of the artifacts, for the versioning of the artifacts and for the maintenance of the artifacts. And for the version based, if you want to deploy, then we can deploy if the artifact will be uploaded to this SonarQube server. Sorry, this is the Artifactory. So now the Artifactory will have the different build files. Maybe it will have the jar file, or maybe it will have the .exe. Let's say this may be the jar file, and it may have the build for the let's say Python build file. Maybe you can say it as pybuild. Yeah, maybe let's say pybuild Python build files, or maybe it will have the .exe files, Windows executable. Let's say .exe file. So that is Windows executable file. If it is the .NET applications. So these are all the artifacts that the Artifactory holds. Of course, with the versioning, that is the important. Right. Next, this I'll give the time to ask the questions. Please be ready with your questions. I definitely will answer your questions, but let me first complete this flow. Fine. Now, each and every microservices respective artifact. So whatever the artifact generated, where artifacts will be generated. So the artifacts will be generated on the worker machines, correct? So here artifacts will be generated here. For each and every microservice, maybe the different artifacts will be generated. So this is one artifact, right? So maybe we'll have the PyBuilder, meaning Python build artifact on this machine probably, and maybe we'll have the .NET build, that is the .exe builds. So probably these are here. Okay, so these are what the artifacts will be built and then generate on the Jenkins worker nodes, not on the master node. Master node will have only the job definitions, pipeline definitions, whereas the pipeline will be executed on the worker machines. Okay, so this pipeline definition and also the plugins. The Jenkins will have the pipeline definitions and also the plugins. So let's take this Jenkins logo. Probably I can take this logo. So it will have the this is the Jenkins server. Fine. Then after that, what we will do? Now the artifacts of all the microservices were on the Artifactory. Then what we will do? So we'll take the help of the Ansible server now. We'll take the help of the Ansible server now for the configuration management. So we'll take the Ansible server. So what this Ansible server will do? So let's say, yeah, let's take this logo. One minute, let me capture this logo. Yeah. So what this Ansible server will do? Configuration management. This will do the configuration management. So in Ansible, what we will do is we'll create the different directories. Let's say one directory will create as the category service directory. This is the category service directory. And this is the branch service directory. This is the API gateway directory. And this is the, let's say, authentication service directory. And this is the user management service directory. So likewise, we'll create different directories on the Ansible server machine. And on these different directories, what we will do? So onto this different directories, we'll copy the files of the, that means now if this pipeline is the build pipeline, not deployment pipeline, build pipeline, let's say. So each and every directory will be having the Docker file. Each and every contains the Docker file plus JFrog script file, both files, Docker file plus JFrog script files. Both the files will copy to this, let's say, vanilla monolithic pre-clinic application. One moment, guys, just let me showcase this. Yeah. So what it contains the Docker file. So each and every directory contains the Docker file. And also, let me just increase this. One moment. This is the directories. So on Ansible server, because this blueprint we will follow while we are setting up this pipeline for this microservices deployment, and hence I'm taking little care on here. Okay, so this is what the Ansible server. So Docker file, and also it contains what the JFrog shell script file. JFrog shell script file. Right. So each and every directory contains these two. Each and every directory contains these two. Perfect. Right. Now, this Ansible will do what? Ansible will have the inventory with the target server's location. So let's say target server is the, if you can see here, Ansible architecture, it will have the inventory. inventory, modules, API, plugins, playbooks. This is what its architecture. So it will have the inventory, where this inventory is talking about to which target server it needs to connect to. That means the inventory will be configured with the target server details. So it will have the inventory. So as it have the inventory, it knows the target server details, like to which target it need to connect to. So this is the inventory. Okay, this is the inventory. So inventory meaning it have the target server details. Let's say we have given the target server details as the Docker and then the Kubernetes. So now what it will do, it will connect to the Docker machine. It will connect to the Docker machine. Let's say this is Docker server. Docker server meaning where the Docker installed is what I mean. So, sorry. Let's go with the Docker, and each and every, this is very important. This is very important. This is very important. Please carefully observe. The Docker machine, now each and every pipeline is doing this automation, job. That means what? Each and every pipeline, each and every microservice pipeline is connecting to the Ansible server. Let's say this is connecting to the Ansible server and then copying the files to here. Let's say this is copying the files here, and this is copying the files here, and this is also copying the files onto the Ansible server. Let's say this is copying the files onto Ansible server, and of course other microservices as well. Let's take here as well. Right. So here this also will, this pipeline will copy the files onto the Ansible server. Now, what will happen? Ansible server will have the playbooks. Ansible server will have the playbook. So that playbook looks to be like this, just to have you the awareness. So playbook contains like this. What is the host? Docker host. And on the Docker host machine, with what user we need to execute these commands? With the Docker admin user. So these are all the commands that we need to execute on the Docker machine. So what will happen? Such a pipelines, each and every microservice will have such a playbooks. Each and every microservice pipeline will have one playbook. So this is one playbook. So this playbook is doing what here? This playbook is executing the scripts. Each and every, let me take little here. Yeah. So each and every microservice will contains the playbook, Ansible playbook. So that Ansible playbook contains the script of what? Connect to the Docker machine and execute the commands on the Docker machine. So connect to the Docker machine. Okay, connect to the Docker machine. Copy the Docker file. Copy the Docker file and JFrog machine. Docker file JFrog script by creating one directory on the Docker machine for one microservice. This is for one microservice, I mean to say. Similarly, Docker file and then the JFrog script will be copied here. This is for the second service and third microservice. Let's say the brand service, category service, API gateway, service registry. Then here is the authentication service, and then the user management service. So all these files are copied. Then this Docker file, first JFrog will be executed here on the Docker server by the Ansible. From the Ansible machine, we will connect to Docker server machine, and from the Ansible machine, we will execute this playbook. Then this will connect to this Docker server and then execute the jfrog.sh file. When we execute the jfrog.sh file, we'll get the artifact here. We'll get the artifact. So we'll get the artifact. So from where it will be download the artifact? Latest artifact, it will download from our artifactory. So whatever the latest artifact, that it will download from the artifactory. Right? Maybe the artifact is the .exe. Sometimes if it is the let's say .NET service or py build file, meaning the Python build file, I mean to say, if it is the Python application, like this, the build file will be generated. Now, using this Docker file and using this artifact, the image will be created. Docker image will be created for each and every microservice. For each and every microservice, one Docker image will be created. So let's say this is the Docker image. This is the Docker image. For each and every, using this artifact and plus using the Docker file, for each and every microservice, image will be created. So this is one image, and this is another image. And this is another image. And here also one image will be prepared. Done. Now, Docker images were prepared on the Docker server machine. Then what will happen? These Docker images, these are all Docker images, will be pushed to the Docker private registry, nothing but the Docker hub. So here is the Docker hub. Here is the Docker hub. So the images will be pushed for these. These are all the images will be pushed to the Docker hub. Now these are all the images will be there in the Docker hub. Let's say category service, brand service, right? Authentication service, user registration service, IAM service, cache server. Sorry. All these images will be pushed to the Docker private registry. This will be pushed to the Docker hub private registry. Private registry. Fine. 1 minute, guys. Sorry. Yeah. So now all these microservices will be microservices images will be pushed to the Docker private registry, not public. Remember this. We will, throughout this session, we will push it to the public repositories only. But in real time, the Docker images will be pushed to the private registries or private, repository or private registry will create, we will purchase, or else we also can set up our own registry, and then we can push the Docker images to there. So, but in real time, it will be the private registry, not the public registry. Okay, but as we don't have the meaning private registry is costly, so throughout the session we'll go with the public registries only. Fine. So now the Docker Hub will be uploaded with the Docker images. So this entire flow is called as the continuous integration. Now you can ask your question if you have any on this complete flow. Any questions?
Sir,
yeah.
So like we have single Docker engine and there are multiple microservices. So this will happen in a queue, like first microservice, then second image will be created, or parallel will happen. Image will be created.
It is not queue actually, parallel will happen because this Ansible will do what parallel execution it will do. So only one server, but it will do the parallel execution. So at Ansible, these playbooks will executed on here for each and every pipeline. So when the playbook will execute, automatically this process will go on the Docker machine. It's not one after the other. It's one equal to other, meaning parallel processing, not sequential.
So like Ansible will create multiple connections to same server at the same time.
Not multiple connections, only one connection, but the multiple tasks will be executed. Whereas each and every task, nothing but running this playbook. So if you see, this playbook contains these tasks, multiple tasks. So host is only one, but these tasks will execute parallelly. Got it? Huh?
Oh, okay, sir.
Yeah.
One question, sir. So the steps, what are there into the Ansible playbook? That can be part of the Docker file as well, right? What we can club with the code.
No. Yeah, code, it will be part of the code, but not with the Docker file. So if you can see here, this is the code. So it will be part of the code. Playbook will be the part of the code. But these instructions should not be in the Docker file because Docker file syntax, semantics are different. Playbook syntax, semantics are different. Docker file is read by the Docker engine. Playbook will be read by the Ansible engine. So both are too different altogether. So we should have to create a separate playbook and separate Docker file. Instructions written in the Docker file can't be executed by the playbook, or instructions written in the playbook can't be understood by the Docker file. But both will be maintained as part of the source code. Got it? Huh?
Yeah, I mean, the instruction like copy and all is done into the notebook, right? So the same thing can be done as a part of Docker file as well, right?
That copy different. The copy instruction in the Docker file is different, and here copy is different. So here we can execute the shell, but Docker file we can execute the shell in different way. So what I mean to say is here tasks is there. This tasks is not understanding by the Docker. This tasks is only understood by the Ansible. Similarly, Docker contains the instruction called, let us say, work dir. That work dir not understood by this Ansible. So we can't, bridge these two together. This
okay, one more point. So these instruction or the shell task is a part of this Docker file notebook. Sorry, Ansible notebook. So correct, these commands can't we have at the Jenkins as a shell?
One thing is what? Yes, these commands we can have. Directly on the Jenkins as a shell. But Jenkins shell. But the problem here is Jenkins server is heavy loaded one. heavy loaded one with a rich UI, lot of plugins and all. So if all the microservices related execution is also taking care or taking by this Jenkins, we will get a lot of performance issues. That is the reason that Jenkins will be free up with the configuration, free up with the build execution. So we need to hand over this configuration and then the build execution jobs to some other servers. So we can have these are also on the Jenkins machine. Yes, absolutely. But performance wise, let's say we may have the 100 build jobs, right? So 100 shell scripts will be executed. Performance will be definitely degraded. And here the shell scripts also, Jenkins shell scripts also will execute parallel, but performance problem, Jenkins machine will be overloaded. So that is the reason we'll take that job to lightweight server called Ansible.
It's like we are doing coupling and cohesion over here,
exactly.
Right?
Correct.
Because most of the people projects are not having Ansible. That's why I'm asking. So maybe
most I don't agree, but it depends on the people. Many of the projects, complex projects, definitely will have the Ansible. Configuration management server is damn required. Maybe it depends on architecture, depends on how size of their microservices. If it is simple, single monolithic application, maybe they don't think they need the Ansible server. But if it is complex architecture like microservices, damn sure Ansible is required. Altogether, we need to achieve the performance. Performance is the bottleneck, right? So, got it?
Sir, the Docker file will be transferred from the Jenkins worker to the Ansible server, right?
Correct. Jenkins worker to the Ansible server. That's true. But we can't refer like this because the SSH connectivity will be established, of course, between this worker nodes and then this Ansible server. But Ansible server machine will be configured as part of the Jenkins SSH plugin. So we need to refer like this only. We should not refer from here to here like this. No, this is not correct.
Okay.
Hello.
Worker
Yes.
In real time also, these machines use only T2 type micro machines or use larger machines?
Based on the source code that going to be keep on these machines, and based on the size of the artifact that it is going to be built. So these machines will be taken. If it is microservices, for microservices, T2.micro is good enough.
Okay.
But if it is not microservices, monolithic application, like as we discussed, right, all the modules will be in the single, this is, if it is a monolithic application, T2.micro doesn't enough.
Yes.
We have to go for minimum T2.medium.
Okay.
Yeah.
Got it. Thank you.
Sir, for database, we will take the images from the public repository.
Correct. Hub.docker.com. Yes. For database, for IAM, or for the cache, for all of them, we'll take the images from the hub.docker.com.
I have a question. From the Artifactory, the image will from the Docker server to Artifactory, or the Artifactory, and once the Docker file from the Docker server it transfers to Artifactory.
Yeah. So let me explain this flow. So this Ansible server will do what? If you can see the scripts, first Ansible is doing what? Connecting to the Docker host machine. Then copying the jfrog.ssh from the Ansible server to the destination, that is the Docker. So jfrog is transferring from here to here. Then after jfrog transferred, what it is doing, it is executing the, then copying the Docker file, then changing the permissions, then executing the jfrog. So that means what? Once the jfrog copied, once the Docker copied, here it is executing. When it is executing this jfrog.sh file, the jfrog.sh file contains the script to connect to the Artifactory, repo, particular repo, right? And then username and then password. Of course, these passwords we can take encoded or encrypted as well. So finally, it is connecting to the artifact server and then downloading the artifact for us. So, sorry, artifact for us. So that artifact is coming up here. So when this playbook is executing, Docker file is copying, JFrog is copying, JFrog is executing, and Docker image is building, if you can see, and building the Docker image and pushing the Docker image. Everything is happening while this playbook is executing. This entire operation on the Docker server is happening via this playbook execution. Got it? Huh? Got it, right?
Yes, yes.
So
Okay.
like in Docker server, multiple building of image will happen. So this should be like heavy server, Docker server.
Correct. This should be heavy server. And once after the build is done and then the Docker image will be pushed to the private registry, we should have to remove the image from the Docker server. That is the best practice. We must and should have to remove the Docker image from the Docker server once it published to the Docker registry.
So that we can do through the automation because it's very hard to manually remove all the time.
Correct. Automation only. See this, once we push it, then what we can do? We can write one more, playbook, like a clean, clean playbook, or as part of this playbook instruction, one more instruction we can take, like remove, Docker RMI-F, then remove the image. We know the image name here. So tag we know. So remove that tag. That's it. It will be removed. So it is one more instruction we're going to add here. That's it. Got it, right? So it automatically will takes care about the removing of it. So this is the complete automation when the programmer will be, do the changes to the respective microservices, different programmers may be there. So when the programmer will do the changes and then push the code, done. Everything needs to be taken care by it. So here we need to take a webhook. So let us take the webhook. So this is the logo of the webhook. So let me take this. So here webhooks we will configure. So here is the webhook. So these webhooks will trigger the event to the respective pipeline to execute or pipeline to pull the code when the developer will commit the code. That means merge the PR. When the PR will be merged and these hooks will inform to these pipelines.
Hello, sir.
Yes.
To the SonarQube server, we will use MongoDB to connect.
No, we will use the Postgres SQL.
Okay.
Yeah, here we'll use Postgres. Let me take the Postgres SQL. Yeah, so let's take the Postgres. RDBMS support is given. Of course, Mongo support also might not given. But
Sir, which tool you are using to capture the image?
I'm using the, I didn't remember what is that tool. This one. What is that tool? Lightshot. The tool name is Lightshot. Okay. So this is what these are what the CI continuous integration.
Sir, we have to remove the artifact also once the image is pushed to the registry from Docker server.
No, artifact should be there. That is the whole. Oh, okay. You mean to say from the Docker server? No,
yes,
artifact we can remove, but however, the artifact will be override. When the next will happen, the same artifact will be override here. So one artifact, if we keep, that is also fine. Or else it will be override. That is also fine. We can remove because ideally, for every automation, for every push, definitely the Docker server will go and then get the latest artifact from the artifact tree. Yes, we can remove the artifact also from the Docker machine to make it lightweight.
Okay. Okay,
we
sir.
can do that. Yeah.
So
Okay.
one
So
small doubt, sir.
yes.
This pushing of the images as well as like into Docker server, that can be done in the part of Jenkins itself, or Ansible is required at all? Because like in our company, like we configure everything into the Jenkins itself,
Correct.
pushing the image into the Docker and other things, into the public, private registry. Everything is happening through the Jenkins itself. We're not using any Ansible. Maybe
Correct.
like what he told, it could be a very small project. That's why we're not using Ansible.
Correct. So that's what infra based on the performance, the decision of the configuration management server will take place. So yes, from the Jenkins also we can directly, have the Docker plugins. So using the Docker plugins from the Jenkins directly, we can push the things to Docker registry. But in my opinion, that is not the right pipeline. Of course, maybe it depends on the length of the project, and then the how frequently we will give the these pipelines will be executed. For example, if we can take the Amazon, Flipkart, Amazon at least pipelines, per minute 2000 commits will be happening per minute, 2000 or about 2000 commits will be happening per minute. So if that is the case, see how our pipeline should be more scalable. Correct. So here also our microservices are continuous deployable, meaning continuous improvements happen to these microservices. So that is the reason I'm making everything as loose couple, so that the performance will be good, and Jenkins master will be never stressed with the load of the build execution. Just it will have the plugins and then the configuration. That's it. Got it?
Yes, sir. Thank you.
Yeah.
One more question. If move to the Docker server.
Yeah.
So from the Docker server, the build is going to Artifactory. Am I right?
Okay. No, that is not correct. Here, build will be generated on the worker machines.
Okay.
So once the build will be generated on the worker machine, next this build will be pushed to, or this build will be uploaded to our Artifactory. So build.
How is the flow?
Yeah, this Jenkins master we will configure the build pipeline. In the build pipeline, we will take the Artifactory server details, where we want to push, and we will use the maven deploy command. So when we use the maven deploy command, the deploy will deploy the artifact in the target server. So we'll mention in the pipeline maven deploy, and this is the target server. So then this artifact will do what? This artifact generated on the worker machine will be uploaded to this Artifactory. Once the Artifactory uploaded with the artifact, then the Ansible flow will start. That means the Ansible server, meaning we will connect to the Ansible server, and then on the Ansible server, meaning we'll copy the files to the Ansible server, and then we will execute this playbook on the Ansible server. So this is what the pipeline we're gonna build. So this is what the pipeline we're gonna build. So you can see here, copying the files to the Ansible server. So we are connecting to the Ansible server and then copying the Docker file, JFrog, playbook to the Ansible server. Then again, we are opening the Ansible server in the time to live mode, and then we are executing the commands on the Ansible server. So meaning Ansible playbook, and then we are executing this playbook. When the playbook will execute, it will connect to the Docker host machine and execute all the commands on the Docker host machine. Then the image will be prepared, and the Docker push will be happened to the registry. Image will be pushed to the registry. After the image will be pushed to the registry, then we are immediately starting the deployment job. One more deployment job we are triggering. So This is what we discussed so far is the just CI job, continuous integration job. Now CD job will be triggered. Once after this is done, then CD job will be triggered. That CD job again contains the Kubernetes files in the register, in the repository. Those Kubernetes files will be pulled by the pipeline build jobs and copy those Kubernetes files to Ansible server. Then Ansible server playbook will execute, and that playbook will deploy the files onto the Kubernetes cluster.
Okay.
That is the flow.
Got it. Thank you.
Yeah. Okay. So any questions? Any more
Small
questions? Yeah.
So in this pipeline, where exactly the test cases will execute? I mean, that is my first question. The second question is, based on the test cases, we can check this sonar gate and quality checking, or after the test cases we can do it.
Okay. First of all, we will do, for example, if it is the Maven project, so we'll have the life cycle, not only Maven, anything you can take, life cycle will be there. So as part of the life cycle, first clean, then package, then install, then verify, package, verify, and then install, then deploy. This is the steps. So once packaging will be built, meaning the jar file or var file or .exe file, whatever it is, once the build packaging is done, then verify is the stage where it will connect to the SonarQube server. So it will verify this package is done fine, but this package contains, meaning package when it executed, and package when it done, okay, package is done fine, but this package is done using the source code. That source code having these test cases. So test cases executed, right, as part of this package before only the test cases will be executed. So whatever the test cases executed, that test reports will be analyzed by the SonarQube server. And quality gate, I mean to say, in the quality gate, we will mention, let's say test cases 50% are passed, then pass the gate, or test cases 60% passed, pass the gate, or test cases 30% of the test cases will fail, then fail the gate. So such a conditions will write in the quality gate. So as part of this verify stage, this pipeline will, meaning this quality gates will evaluate the build is qualitative or not. As part of this build evaluation, it also will, check the test cases and test cases execution results count and all. It will take care. It will check. Got it? Huh? Am I answered?
Got it.
Yeah.
Okay. So like we have different environments of QA, staging, and dev and prod. So each environment will have separate pipeline.
Not pipeline, separate setup. Each and every environment will have entire separate setup.
Okay. Oh.
Sometimes will have what will happen, QA and dev may have the same setup, whereas the QA will have the QA Docker server and QA K8s cluster. That's it. Till here all are same. Only the changes, QA will have the QA Docker server, dev will have the dev Docker server. Rest all are same. But going to the upstream environments like UAT or pre-production or PT, performance testing, they're altogether a new environment, meaning the same to same pipeline will be replicated there with the different infrastructure, meaning it is not the shareable one. It altogether will be a different infrastructure. New Jenkins machine, new worker machines, Ansible server, Docker, everything. This will be copy of this infra, copy of this pipeline will be happened onto those machines.
Yeah.
Okay, right?
Thank you, sir.
Yeah.
Thank you, sir.
But the artifactory generated, it has to the same artifactory has to deploy should deploy in all the environments, right? Why we should build a separate artifactory for UAT and production?
Here, what will happen is the same artifact will use same. That is true. Artifact will use the same. So what will happen is just to have the code cleanup. For example, branch cuttings will be happen. So let's say 3-4 features will have one branch cut, and then that branch cut is tested well or executed well in the dev environment, let's say. And that branch cut, whatever the branch, whatever having the 2 to 3 features, those branches again will be, executed and then deployed on the other servers. If we use the same artifact here, same artifact, same build, the problem is what, the development will be keep on happening. So every time the new artifacts will come here, what we have to do, we have to deploy a particular version of the artifact if we don't want to maintain a separate build mechanism again. Of course, our cloud native principles are saying what? Build only one time and use that build many times, anywhere. Aura. So Aura is what the principle it is talking about. Write once, read anywhere. So build once, deploy anywhere. So that concept is there, but practically that concept is, someone is practicing and some people are not practicing. What I mean to say is, if you want to deploy, let's say development having the 10 features, maybe 10 features we don't want to deploy onto the production. Let's say 3 features, 4 features we want to release now. Okay, if that is the case, then separate building is required with the particular 3 or 4 features. Got it?
Yeah. Yes, sir.
Yes.
Sir, actually, I understood the overall pipeline concept, but I'm new to this Jenkins and Ansible. I understood bits and pieces of the flow. I'm trying to understand that Ansible part that is totally new for me. What are can you give some brief, just a small 1 minute or 2 minute explanation about what exactly, why should we use this Ansible, and what are the jobs that we can configure here in real time?
Okay, so first of all, this Ansible is doing, by this diagram, what we understood, first of all, Docker file, JFrog, playbook, these are where? These are in the source code, first of all. But these are all finally reaching to where? To the Docker servers. So this Ansible is doing what? Lifting and shifting of the configurations it is doing. It is taking the configuration files from here to here, target server. Point number 1. Next, after the files are lifted and then shifted, then executing these files, whatever it is shifted onto the server from this Ansible server. Let's say 100 servers we have. Basically, why we go for this configuration management servers, for the parallel processing execution. So this JFrog file take it 2 minutes on this one. If there will be no Ansible server, what will happen? This JFrog, meaning one JFrog script to take in 2 minutes, then this will take 2 minutes, then this will take 2 minutes. Overall, 5 microservices will take 10 minutes. But if the Ansible we have, as the parallel processing is happening, within the 2 minutes, 5 JFrog scripts will be executed for the 5 microservices to download the 5 artifacts. So parallel processing is doing. And this Ansible server will have a beautiful concept called inventory and then the modules. In the inventory, it will have the list of servers to which it needs to connect to. And it will connect to those servers parallelly at a time. Parallelly, it will connect. So on 100 machines, if it will take 100 minutes to do some job without Ansible, then with the Ansible, it will take 1 minute to do the job, same job on the 100 machines. So that is what the Ansible server is. Got it? Huh?
Yeah, sir, I'm just relating with some of our projects. It is already built. Like I'm into programming. I never gone through this Jenkins, those stuff. But in our organization, they are using Lightspeed, and they are using udeploy, and just correlating those tools with this architecture.
Okay.
Where exactly fits, meaning this Ansible is replaced by Lightspeed, or where exactly it can be replaced? What are the other alternatives of Ansible? If not Ansible, what is the other product, other software that we can replace with this?
So configuration, let's see, CI/CD configuration tools or Ansible alternatives. Let us see them. Ansible alternatives. So we have the 8 best Ansible alternatives. They are saying one is Rudder, Salt Stack, Puppet, CF Engine, GitLab, of course Jenkins, CodeNV. So these are all we can use even without Ansible or as an alternative to the Ansible as well. Configuration management we can do. So maybe there were different tools. Lot of the problem with this DevOps tools is what, hundreds of tools were there in the market now. So which tool we have to choose, right? That is based on the open source versus the paid, and framework versus the the manual configurations, or framework versus the setup configurations. Many things will come into the picture, but yeah. So these are what the alternatives to the Ansible. Maybe we may have a lot more others as well. Not only this one, lot more others as well, alternate tools, but these are the topics is what they are saying. Okay.
Yeah.
Any more questions? Yeah, clear, right? Any more questions?
Sir, as a part of this course, you will be covering Kubernetes with 4 microservices, right?
Correct.
Okay, so is this a part of some ongoing program which is already there? And we are communicating
the
on
Kubernetes.
the Jenkins part. So is it an ongoing program?
First of all, we'll focus on the Kubernetes. First, we'll target to finish the Kubernetes concepts, Kubernetes, exercises, whatever it is. So entire course content of the Kubernetes will complete. Then what we will do, that Kubernetes will integrate with this already existed pipeline. So now the pipeline already existed for the monolithic application deployment. So we will write the different pipelines for the different microservices. So microservices were already there for us. Already development is happening now. Microservices development is now happening. By the time of we complete the Kubernetes, all the microservices ecosystem will be completed, meaning API gateway, service history, authentication servers, authentication, configuration, cache, almost all done. API gateway and few are pending. So that development is partly happening by the Java real-time project guys. So what I mean to say is, by the end of the Kubernetes discussion, we will be ready with all the microservices, including the ecosystem components. Then we will write the pipeline script for each and every microservice on the existed setup. So this setup, Ansible, worker machines, Jenkins master, and then the SonarQube server, Artifactory, Docker server is not there. At least these setup we already have. So SonarQube, Artifactory, Ansible, Jenkins, workers, this setup already have. So what we'll do, we'll integrate this Docker, and then we'll integrate the Kubernetes. Then we'll test the end-to-end flow. Got it?
Yeah, so this is my second, this is my first day of the class. So I missed yesterday's class. So is any possible I can get any recording session to review And
Yep. So they will share today, how many members joined? For all those members, the yesterday and then day before yesterday, this is the fourth demo. So all 3 demos videos will be shared to you. So they'll share the link of the demos.
okay, thank you. So when is the actual class will start after that?
Hello, sir. Video
Yeah.
is already uploaded in YouTube.
Correct. Videos are uploaded in YouTube already. That YouTube link they will share. So from Monday onwards, let us jump into the concept, because you now got overall picture what we're going to do throughout this course. Then from Monday onwards, let us start the Kubernetes concepts, understanding Kubernetes architecture. Let us understand from Monday onwards. So from Monday onwards, our actual content will be begin.
Okay, thank you.
Narsi, I have a small question here.
Yeah.
You are saying that already this SonarQube, JFrog, and these things are already available for the monolithic, right?
Yeah.
Already. So the same infra we are going to use for the microservices, you are saying, right?
Correct. Yes.
So suppose if you want to practice this thing, we require some kind of guidance here, right? So can we get the documentation or something what you teach, or some kind of
document, step by step executable documents I'll provide. It is step by step. You just need to copy and then paste the command in your shell. It will be come up for you. Okay.
Okay. It is an on-premise or it is a cloud?
Any cloud you can take. On-premise it will work. Any cloud it will work. We are targeting for what it is, cloud native applications we are building, and then targeting for the cloud agnostic. So any you can take. GCP you can take, Azure you can take, or AWS you can take. On anywhere it will work.
Okay. Thank you.
So Narsi, as a part of this course, this Kubernetes plus CI/CD is covered.
No, not complete CI/CD. Kubernetes plus microservices deployment will be covered. Not complete CI/CD. If it is complete CI/CD, then again I have to come from the SonarQube, Artifactory, Jenkins, Ansible, all these things. So that is again a 45 days course. So I'm not doing that. So Kubernetes complete plus microservices deployment in the Kubernetes via this CI/CD pipeline, how it will be in real time. That is the concept. Yeah. Okay.
Sir, if you have few minutes, can you please explain one module? Like, can you take a category module, and can you show us that Docker file, JFrog SH file, and playbook XML? And can you show how the flow goes in our diagram? There is a pipeline setting, and Jenkins master will pull that code.
Correct.
And from there, it flows to SonarQube server. And once the gateway passes,
correct.
So it will hand over to worker nodes, right? So
No. Whatever the pipeline we have configured here, that pipeline will be executed here on the worker machines.
Executed meaning the files, Jenkins file, and those files will be executed here.
Correct. Meaning the source code will be pulled onto this machine, and then the artifact building will be happened on this machine, and artifact will be generated on this machine.
Can you please show us that file? What is a file? It is read by this build machine. Jenkins file, right?
Jenkins file, correct. This is the Jenkins file.
Okay.
Yes, this is the Jenkins file.
These are the stages that. Okay.
Correct. Don't worry. This again I will explain while we are building the pipeline. This everything I'll write from the scratch. This is a Groovy script, very easy, and Jenkins have the facility to provide these steps for us. What is this pipeline? What is this agent? What is this tools? What is the stages? Parallel stages. So many more things we will discuss actually while this course is happening. But as the question you asked, see, this step 1 is doing pulling the source code from the source code repository. And it need to be pulled on what? Pulled on any agent. Any agent in the sense, we have these all worker machines now. On any of the worker machine, on the any of the available worker machine, the source code will be pulled onto any of the available worker machine. That is the meaning of it. Okay, so once the source code is pulled here, then the next stage is what? We are building the source code and then getting the artifact. Once the artifact we are getting, then
sorry to interrupt you, sir. So let's say, for example, Java application. So artifact means it is a ER file or jar file, right? So okay, packaging means ER file. Okay. So that is declared in our Jenkins file, like it is part of our Maven pom.xml, correct, sir?
Correct.
How our pom.file is executed and how this ER file is generated, how this is mapped and it is copied to Artifactory.
Yeah, so these are all ongoing. We'll discuss actually. If I discuss everything in the demo, maybe that doesn't make sense. But as the question asked, let me showcase you something.
Sir, sorry to interrupt. Sir, can we drop or class is over for us?
Yeah, otherwise you guys can drop. Today we thought of setting up the Kubernetes cluster, but we'll set it up on Monday. On Monday we will set the Kubernetes cluster. You guys can drop off.
So tomorrow no class, right?
Tomorrow no class. Again from Monday onwards, regularly we'll have sessions as usual. And folks, remember one thing, please. 27th, 28th, and then 1st. No sessions because I have the my visa interview in Mumbai. So I need to travel to Mumbai. So 27th, 28th, and then 1st. These 3 days classes are not possible for me. However, once the Kubernetes session started from tomorrow onwards, whoever the registered users, meaning registered members, for them also I will inform. And our DevOps guys and then the Java guys, 27, 28, and 1st. Classes are not possible for these 3 days. So coming 24th and then 26th, let us spend a lot of time on the Kubernetes and then we'll cover the stuff required for this 27 and 28 and then 1. From the 2nd, 3rd, and 4th, again usual, and 4th and 5 will have a longer sessions. Okay, so 27th, 28th, and then 1st, no classes.
Okay, so please upload the documents in the DevOps classroom also.
I'll take that. I'll take that today. Meaning Kubernetes, all the Kubernetes documents I'll upload today.
Yes, and so just one more thing, so that Shopify backend code is not working. That you uploaded yesterday.
I uploaded. I have uploaded the suite, complete suite uploaded yesterday.
Yeah, so that also is having some problem.
No, it don't have the problems. I'll tell you how we have to execute. So this is what I uploaded. I think it's uploaded in DevOps or DevOps, I believe. One moment. DevOps classwork source code. So this is the suite. Once the